I once wrote a query that crashed an executive dashboard. Why? Because of a missing join criteria. Tens of thousands of rows, totally wrong, and I didn't catch it. The kicker here, the query ran perfectly. SQL doesn't break when you write something wrong. It breaks when you misunderstand how it works. Today, we are going to be lifting the hood. We're going to be talking about some execution order, join logic, window functions, and how one mistake blew up my data. SQL reads differently than it writes. Here is the real itinerary for your SQL query. Here, we start out from the departure gate with your from clause. We're talking about what table is this coming from. Next, we roll into where. So this is kind of your security check. We are filtering things like who doesn't meet the criteria. Next, we run into group by here at the terminal lounge. Who belongs together? What groups, what aisles maybe people are going to. Next, we have our having. This is your VIP clearance. Who gets through the premium filter? Next, we finally circle back to that select statement. This is kind of your seat assignment. What do we really care about? Finally, we land with the order by. This is your exit gate. Who is leaving first? Most devs write the SQL first, and that's where we run into the first problem. Me, I write the word select first, and then I directly go to from. I leave a couple of spaces in between and jump right into my from criteria. And if you don't know how SQL thinks, then you don't think about doing that. You'll debug the wrong part of the query, and so you have to remember your joins happen during that from step. So if your join logic is bad, the rest of the foundation for your SQL query is broken. This isn't just a technical issue. Misunderstanding execution steps can really lead to incomplete reports, missed KPIs, and eroded stakeholder trust. So quick check. Can you recite SQL's execution order out loud? Try it. If you can't, go back to the beginning, take a look at that SQL order and try it again. Let's talk about joins, baby. Let's talk about you and then da 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 da. Okay, so enough being silly. Let's talk about join. Imagine you have two lists. One, your invitees to a party. The other one, who's bringing what to the party. Sound familiar? It's very close to the scenario that we have in real life where you might have a customers table and a transactions table, maybe a sales transaction table. So we're going to use this as our example for our join logic. First, let's talk about inner joins. These are the things that match between the two tables. So this is just those matches, the people that are invited and are also bringing something. So for example, if they got invited but they're not bringing something, then they're not going to show up. If they're bringing something but didn't make it to the invited list, also not going to show up on the results of this query. Next, we have our left join. This is everybody that's invited, even if they're bringing nothing, and the associated item that they're bringing. After that, we have our full outer join. This is everybody, right? This is everybody that was invited and is also on the who's bringing what list. Now, in this case, this happens regardless of whether they're matched or not. So, for example, you'll have one column with your list of people that are invited, one column with the list of names of people who are bringing stuff, and then your column of items that they're bringing. We have the Cartesian join. This one is dangerous. This is everybody matched to everything, and it is chaos. So for example, if you have Bob is invited and you have people bringing chips, desserts, drinks, cups, and plates, Bob makes it, this query will make it look like Bob is bringing chips, plates, cups, everything that is on that items list as well. and along with everybody else that's invited, regardless of whether they show up on that bringing list. So, just chaos, not normally the results that you want. Now, forget about your on clause, and boom, the Cartesian join is what happens. All of a sudden, you've got 10 million records of just junk data. It looks like data, but it is all just noise. So, one real world scenario where I fell into an issue, I hinted at this at the beginning of the video. I once used a inner join here instead of a left join. And it was for this Salesforce report. And for half the month, none of our new leads showed up in our Salesforce dashboard. Our funnel looked $5 million under target when we actually ended up being more than $2 million over target. Leadership started pressuring marketing for answers, asking where their leads were, even threatening to pull the budget if they couldn't start showing results. One wrong join nearly tanked a whole marketing campaign. This is how you inflate revenue, tank team morale, and really destroy confidence in your data team. So pause here and tell me, what join do you default to when you're writing your queries? Do you automatically say left join? It's a habit a lot of us get into. Let me know down below and tell me why. If you've ever fallen into a situation where you wrote a query that returned way too many rows, go ahead and hit that like button right now, because you are not alone. We've all been there. All right, let's play a game. For the Price is Right fans that are out there, there was this game called the range game. And you basically slid a window up and down over a price range. And if the item lands, for the price for the item lands in that range, then you won that game. So that's very similar to window functions, except there's the prizes that you have happy stakeholders. So, so window functions really do a lot of the same thing. You define a range around each row, previous, next, or both, and calculate something over it, whether it's sum, average, maybe a ranking, things like that. So here you see an example where we are selecting our date, our sales, our average sales over this period from our daily sales table. You'll notice here that compared to normal aggregations, we actually don't have a group by statement in this. So too small a window, and you start to miss the patterns that you're looking for. Too large, and you drown out that signal in just a bunch of noise, and it doesn't make any sense. So again, I talked about this just a second ago. Group by collapses rows to produce one result per group. Window functions keeps all the detail, keeps that granularity that sometimes you still need, and adds this calculation alongside of it. Think filtering versus annotating. So these functions power 90% of analytics out there. Rolling averages, ranks, cohorts. If your team doesn't get this and isn't using this, they're not analyzing, they're just guessing. What is your go-to use for window functions? Is it ranking, moving averages, or maybe something completely else? Let me know down in the comments. All right, last data word for today, and it is actually going to be SQL itself. The OG. Born in the 70s at IBM and still running every serious system that you run into today. SQL is declarative. You tell the system what, not how, and it has sublanguages, which you might not even be aware of yet. So let's take a look. We have our DDL, which is data definition language. These are things like create, alter, drop. We have DML, data manipulation language, which is our insert, our update, our delete. We have DCL, which is your control language. So these are your grants and your revokes. This is the sublanguage that you see DBAs use a lot. We have TCL, which is finally, again, another part of our transaction control language, which is our commit and our rollback. So more about some of these individual types of SQL queries later, but that's what I wanted to cover today. Everything we covered today, SQL really gives you the control to define every piece of that. Most folks use 10% of the whole SQL language, just like a lot of people use 10% of their brain. If you think SQL is outdated, ask why Snowflake and BigQuery, dbt, and even Power BI still use it every day. Comment down below with your go-to join or SQL bug that wrecked your day. And if you have ever had to explain join logic in an interview or postmortem, be sure you check out Lesson 3 of our Data Engineering 101 series and make that your next step in your data journey.